Alex, people look at a laser cutter and think it's just a high-tech printer that happens to spit fire. They think you just hit print and go grab a coffee. But man, the first time I tried to cut a simple gear out of quarter-inch oak, I didn't realize I'd basically built a very expensive, very localized campfire in my shop.
Wait, so your grand debut into digital fabrication was almost an insurance claim? I'm shocked. Truly. But honestly, I get why people think that. It's a literal beam of light doing the work. It feels like science fiction until you're the one standing there with a fire extinguisher.
It really is the ultimate expectation versus reality machine. People see these pristine, delicate lace patterns on Pinterest and don't see the 4 hours spent scrubbing soot off the back of the plywood because someone forgot to check their air assist. It's a tool of precision, sure, but it's still a beast you have to taming.
Okay, so before we get into how to prevent your shop from turning into a BBQ pit, let's ground this. For the folks who are just curious, what are we actually talking about when we say laser cutter? Is it just a CNC machine with a lightsaber?
That's actually a pretty solid mental image. It is a CNC machine, computer numerical control, meaning it's taking coordinates from your software and moving ahead along an X and Y axis. But instead of a spinning metal bit like a router, you've got a CO2 or fiber laser. That beam is so tightly focused, it's thinner than a human hair. It's essentially a thermal process. It's not cutting so much as it is vaporizing or melting a path through the material.
And that's the big distinction, right? With a wood router or a saw, you're creating sawdust. With this, you're creating, well, fumes and heat.
Exactly. And that leads us to the two main modes people use, vector and raster. If you want a shape, like a star or a gear, you're doing vector cutting. The laser follows a path like a pen on paper, but it's dialed up to stay on long enough to go all the way through.
And the rastering is the etching part, like printing a photo onto a piece of stone?
Precisely. The laser head zips back and forth, turning on and off in tiny pulses to burn a pattern into the surface. It's like those old dot matrix printers, but with way more soul.
Looking at the specs for some of these professional shops, like the ones at CCA or UNSW, they have machines ranging from 60 watts to 100 watts. If I'm a beginner, does wattage actually matter? Or is it just a mine is bigger than your situation for makers?
Oh, it matters. It's the difference between a brisk walk and a sprint. A 60-watt laser is like a sharp pocket knife. It'll get through thin plywood and acrylic eventually, but it struggles with the thick stuff. You jump up to a 100-watt machine and suddenly you're cutting through half-inch material with the ease of a hot wire through butter. Plus, more power usually means you can move faster, which prevents the wood from sitting there and charring into a crispy mess.
So, speed and power are the two knobs you're always fiddling with. I've noticed that when you're working, you're constantly doing these tiny test squares in the corner of your material. Is that just a nervous habit, or is there a method to the madness?
It's the only way to keep your sanity. Every piece of wood is its own person. You might have 2 sheets of birch plywood from the same stack, but one has a big gob of interior glue that the laser just can't punch through. If you don't run a test to find that sweet spot where you're using just enough power to clear the back, but not so much that you're setting the honeycombs on fire, you're just gambling with your material budget.
Let's talk about the list. I saw a material list earlier that included everything from cardboard and fabric to concrete and glass, but then there's the banned list. What are the things that will actually kill the machine or the operator?
This is the part where I get real serious. If you see something like PVC or certain vinyls, keep them a mile away from that bed. When you hit PVC with a laser, it releases chlorine gas. Not only is that a call to hospital situation for your lungs, but it literally creates hydrochloric acid that eats the guts of the machine. I've seen beautiful 5-figure lasers turn into rusted junk piles in a week because someone wanted to make custom vinyl decals.
That sounds like a horror story for shop managers.
It is. Stick to the safe stuff. Acrylic, wood, paper, certain leathers. If you're ever in doubt, look up the SDS, the safety data sheet. If it mentions halogen or chlorine, it's an absolute hard pass.
What about metals? I see people always asking if they can cut steel or aluminum on their home CO2 laser.
Yeah, and that's a quick way to get a reflection that fries your optics. Most standard CO2 lasers, the ones you'll find in homes or craft studios, don't cut metal. They can etch it if you use a special marking spray that the laser fuses to the surface, but to actually slice through a piece of aluminum, you need a fiber laser or an industrial-grade CO2 with some serious oomph behind it.
Okay, let's assume I have a safe material and a machine. How do I actually talk to it? I know we use Illustrator or Rhino, but what are the rookie moves people make when they're prepping their files?
Oh man, where do I start? The biggest one is lines that aren't actually lines. People will bring in a shape they traced, and to the human eye, it looks like a circle. But to the laser, it's 300 tiny disjointed segments. The machine will sit there and stutter its way around the circle, leaving a burned, jagged edge. You've got to make sure your paths are joined.
And the double line trap. I've seen you catch that one.
That's a classic. You copy and paste a square on top of another square by accident. The laser doesn't know you made a mistake. It just thinks you want to cut that exact same line twice. So it does the first pass, and then on the second pass, there's nothing left to cut but the air, which makes the heat skyrocket. You end up with a scorched, oversized hole where your part used to be. Most software has a delete overlaps feature now, and it is a total lifesaver.
What about the kerf? I hear woodworkers talk about it with saw blades, but a laser beam is so thin. Do you actually have to account for the width of the light?
If you're making anything that needs to fit together, like a tab and slot box, you absolutely do. Even though that beam is tiny, it's still vaporizing about zero point 0.1 to zero point 0.2 millimeters of material. If you design a 10 millimeters tab to go into a 10 millimeters slot, it's going to be loose and floppy because the laser ate a little bit of both sides. I usually offset my lines by about half my kerf width to get that satisfying click fit where you don't even need glue.
Speaking of keeping the machine happy, let's talk maintenance. You're kind of a nut about cleaning the mirrors. Is it really that big of a deal if there's a little dust?
Think of it like this. Your car's windshield is covered in mud and you're trying to drive through a tunnel at night. That laser beam is pure energy. If it hits a speck of dust on a mirror, that dust absorbs the energy, gets incredibly hot, and can actually crack or pit the expensive gold-plated optic. I've seen a tiny fingerprint ruin a $500 lens in seconds. Clean mirrors mean a cleaner cut and a machine that doesn't die on you mid-project.
And the air assist? That's the little nozzle that blows air where the laser hits?
That's the unsung hero. It does two things. It blows the flames out so you don't have a flare-up, and it pushes the smoke away from the lens. If you're cutting wood without air assist, you're basically just making a chimney that coats your expensive optics in creosote. It's the difference between a professional finish and something that looks like it survived a house fire.
Seeing something like this map, it makes the learning curve seem worth it. But for someone sitting at home with their first project, what's the Goldilocks workflow?
Start small. Don't try to build a Victorian dollhouse on day one. Grab some scrap cardboard. It's free, it's safe, and it cuts fast. Use it to check your dimensions in your tabs. Once it fits in cardboard, then you move to the expensive walnut. And for the love of all things holy, stay with the machine.
You mean I can't just go watch a movie while it works?
Absolutely not. I've seen a laser hit a knot in a piece of plywood, the wood warped up, caught the laser head, stalled the motor, and within 30 seconds, the whole bed was a fireball. You are the fire department. You've got to be there with your eyes on the beam.
So respect the power, clean the glass, and maybe don't trust the plywood knots.
That's the gospel right there. Laser cutting isn't about the machine doing the work for you. It's about the machine letting you do work you could never do by hand. It's an extension of the craft, not a replacement for it.
You know, it's easy to focus on the tech, but the soul of it is still the design. Whether it's 100 watts or 60, it's still just a tool in your hands.
Exactly. The magic isn't in the beam, it's in the person who knows how to tame it. Now let's get this walnut out of here and see if your measurements actually held up, or if we're starting over.
Hey, if it's loose, I'm blaming your kerf settings.
Fair enough, let's take a look.